Hello, math fans! Welcome to Math Olympiad Academy, your gateway to advanced problem-solving and mathematical reasoning. In Lesson 11, students discover a classic geometric challenge, finding the shortest distance between 2 points in a right triangle, a problem that appears open-ended at first, but resolves beautifully with the right approach. Let triangle PQR be right-angled at R, and let N be the midpoint of RQ. Given that the area of triangle PQR is 1, how short can PN be? Our goal is to determine the minimum possible length of PN. Solution. Before beginning the solution, in Step 1, we introduce two variables that align with the geometry of the problem, a technique that will help us move toward the final answer. Since the triangle is right-angled at point R, the two legs are PR and RQ. Let us introduce our variables as follows. RP equals x and RQ equals 2y. Now, the area of a right triangle is 1/2 the product of its legs. Therefore, the area of triangle PQR equals 1/2 times PR times RQ, which is 1/2 times x times 2y. This simplifies to x times y. And since the area is 1, we obtain the relationship x times y equals 1. In this second step, we express the distance Pn using the Pythagorean theorem. Now, let us look at triangle PNR. It is also right-angled at R, since PR and RQ are perpendicular, and point N lies on RQ. Therefore, we apply the Pythagorean theorem to triangle PNR, which is right-angled at R. We obtain Pn squared equals Rn squared plus Rp squared, which is equal to x squared plus y squared. Step 3. Now, let us rewrite our previous relation. Pn squared, which is x squared plus y squared, can be expressed as the quantity x minus y all squared plus 2 times xy. And since x times y equals 1, it follows that Pn squared equals the quantity x minus y all squared plus 2. Therefore, Pn is the square root of the quantity x minus y all squared plus 2. Hence, the smallest possible value of Pn occurs when the quantity x minus y squared is 0, meaning when x equals y. Under this condition, the shortest value of the distance Pn is the square root of 2. Conclusion. The shortest value of the distance Pn is the square root of 2. I hope you enjoyed this step-by-step solution. Keep practicing, share this lesson with your friends, and don't forget to subscribe to Math Olympiad Academy for more exciting math challenges. See you in the next lesson!